And it is thought that there is a very large subsurface global ocean underneath the surface of Saturn. And it is thought that on Saturn, methane acts in the same way that water does here on Earth. Here on Earth, water exists at its triple point. So it's a solid, it's a liquid, it's a vapor. And on Titan, you have methane doing the same thing. So you have methane lakes, you have methane clouds, you have methane atmospheres, you have methane rain. It's very high hydrocarbon content. This is an actual image of the surface of Titan. The Cassini mission visited Saturn and Titan, and the European Space Agency had a probe on board, the Huygens probe, which was then released down through the atmosphere of Titan, and it took images all the way down until it stopped functioning. But it actually got a pretty decent, some images of the surface, enough to show that there are definitely drainage patterns. There were rivers, there were flow patterns, that at one point in time a large amount of fluid was flowing over the surface of Titan. And this is a composite put together from the Huygens probe of all the images to show a topographic map of the elevation and the drainage patterns on this little moon. Triton is a moon of Neptune. It is basically a captured Kuiper belt object. It orbits retrograde. Its polar regions take turn facing the sun, so it's kind of tilted on its side compared to the other planets in the solar system. This has not been visited since the Voyagers went through in the late 70s and 80s. And it has a lot of cratering. It's a very old surface. However, it does have areas where there are ice volcanoes, especially on the southern polar region, where at certain times of the year there must be enough subsurface movement and melting due to tidal forces here too, that geysers erupt from underneath the surface, and the icy materials sublimate, and then the dust and debris forms a plume that travels out over the surface of the planet. And again, the length of those and the direction shows the direction and the velocity of any wind. Ceres is the largest asteroid, and it's also the only minor planet in the inner part of the solar system. And it is of interest because it is thought to have a large water ice layer underneath the surface. So even asteroids are an important topic of study for looking for water. Comets, of course, have visited the Earth many, many times. They helped the Earth to form the oceans and atmosphere and clouds that it does have because of materials that were brought in by them. We've actually seen this in action. In 1994, we watched the comet Shoemaker-Levy get caught in the gravitational field of Jupiter and broke up into several small fragments, and we watched them disappear into the Jovian atmosphere, one at a time. In 1997, Hale-Bopp came by, and this observation shows a really nice disconnection event as the sun sublimates the icy materials within the comet. It releases the dust and organics that are locked in with those, and they get left behind in the orbit of the comet, and which some of that material enters the Earth's atmosphere as it plows through this debris left behind in the path of the comet as we orbit around the sun. So a lot of this material reaches the surface of the Earth. Both meteors and comets have brought a lot of very complex hydrocarbons to the surface of the planet Earth, complete like amino acids, organics, volatile and stable, alcohols, even buckyballs have been found at the sites of asteroid impacts, meteor craters on the surface of the Earth. So, the comets, of course, come from two places. The Oort cloud, which is a sphere encircling the solar system, a material that got left behind when the solar system collapsed from the spherical cloud into the flat pancake disk shape that it has now. So the material that got left behind is considered to be pristine and an indication of the early conditions of the solar system before it started to form. And of course, there is another ring of comets that in the Kuiper belt between Neptune and the outermost orbit of Pluto. The comets coming in from the Oort cloud, of course, since it's a sphere, come in from all directions, and they are long period comets. The comets that come in from the Kuiper belt are confined to the disk of the solar system, and they are more short period comets and come by much more often. In the interpretation section for this event, remember it is focusing on the history and the processes that formed the features that we see on the surface, the events that we see taking place on the surface of these objects. This is an artist illustration of a glacier, what it would look like on Mars, and this is a feature that we see on Mars. This is the now subsurface equatorial glaciers that actually produce these features, and you can see these same lobate debris aprons just exactly look like the ones that you see on Earth where glaciers have receded and melted. Here are another two different kinds of graphics. They show the depth and the composition of the ices underneath the surface and how they are related to what you see above the surface. So always, if you come across any of these graphics while you're looking, make sure that you use those to study with. Here are two images of Titan to show the smooth and the rough sections. Here is one on Europa, which is an illustration showing how subsurface features, diapirs and warm ice and dikes, are associated with the features that you see on the surface, the ridges and the domes, for instance. So they're remote sensing with a lot of satellites. We do remote sensing for most things here on Earth now. We study Earth by looking down on it. Much more efficient and effective than trying to do it from the surface of the Earth. So make sure that you understand the kinds of instruments that are used and what those instruments are detecting and observing, and all of the different kinds of illustrations and graphics that result from that. For instance, this one on the upper left is a neutron density map on the surface of Mars. So neutron density is basically a map of the distribution of water on the surface, below the surface of Mars. And of course, remember that one of the most, what everybody is really looking for here is evidence of life on other objects within the solar system, whether they be planets or moons. And because even though the Earth is in the habitable zone of the Sun, so was Mars, and Venus was partially in it. So that's what we look for when we look for exoplanets, that habitable zone. And even though the conditions in all these moons that we've been looking at, planets and moons, are very hostile environments, and one would not think they would be a good place to look for any kind of habitability or life forms, remember that here on Earth there are extremophilic microbes everywhere. So there are microbes here on the surface of the Earth that live in extremely hot environments, extremely cold environments, acidic ones, basic ones, where there's incredible amounts of pressure, incredible amounts of radiation. So if they can exist here on Earth in those conditions, then they can exist on most of those moons that are part of this event this year. And the JPL website has a complete history of all missions, past missions, present missions, even some future missions, and you see they have it by planet. Then the asteroids and the comets, they're all listed there. So you can see there's a real lot of them. Some of these planets have been visited multiple times. Some have only been visited once.